Okay, the next topic we're going to discuss is the distance formula. So the distance is just the length of a segment. Now, if we're on the coordinate plane and we have a horizontal segment, or we have a vertical segment, we can just count the length of those segments because a horizontal segment is just going to be directly across, and a vertical segment is just going to be straight up and down. And we can count those boxes on the coordinate plane. But what happens if we have a diagonal segment? Well, we can actually use the Pythagorean theorem because the coordinate plane creates a 90-degree angle. Now, we know that the Pythagorean theorem is a squared plus b squared equals c squared. Okay, now c squared has to be on one side of our equal sign. A squared plus b squared has to be on the other side of our equal sign. So we know that this means exactly the same thing as c squared equals a squared plus b squared. When we are solving for the length of a diagonal segment on the coordinate grid, we are always solving for c. So we can go ahead and go a few steps down, and we can right now say that we know we will have to square root both sides of our equation. So that means we have c equals the square root of a squared plus b squared. Now, let's take a look at our picture. So if the horizontal side is A, then we have angle A up here. The vertical side is B, so we've got angle B over here, and then our right angle is angle C. Now, if we look at side A, so little a, we know that that is parallel to our x-axis. So that length is going to be the difference in our x values. Now, distance is always positive, so that's why I have an absolute value sign here. Now, the reason why I don't have to plug in an absolute value up here on my modified Pythagorean theorem is because we're going to square it. And even if we got a negative number, a negative times a negative is a positive. So if we put the absolute value, it wouldn't change anything here, but we don't need it because we're going to end up squaring that number, so it's not going to matter. And I'll even go ahead and color code just a little bit more. So our B's are vertical. The B side, that's our vertical side. So we know that that's actually the absolute value of the difference in our Y's, because we know that that's side, you can see over here in this diagram, is parallel to our y-axis. And so that's how we get the distance formula. The distance formula really is just the Pythagorean theorem. We've just gone ahead and moved a few steps down in the problem. We could write a squared plus b squared equals c squared and plug everything in every time, but we know that we're going to get to the point where the length that we're looking for is the square root of the difference in the x values squared plus the difference in the y values squared. So we might as well just go ahead and use that equation. It saves us some steps. So let's take a look. We have line segment RS. We know that R is the point 2, 3, and we know that S is the point 4, -1. Okay, so we need to identify our first point. So our first point is point R, which is 2, 3. Our second point is our point S, which is 4, -1. Now, you technically could have made S the first point and R the second point. You just have to be consistent throughout the equation. So you would have to plug in appropriately based on what you chose to do. Okay, so now we have to find x2 minus x1. So that's our 4 minus our 2. And 4 minus 2 gives us 2. Now our y2 is -1. And it tells us we have to subtract y1. y1 is a positive 3. So -1 minus 3 is -4. So why did I do all of that? Because we were plugging in to our equation. So our equation said that the length of RS would be the square root of x2 minus x1 squared plus y2 minus y1 quantity squared. So I'm just going to, one more time, for clarity's sake, plug in so you can see what I'm doing. So x2 was 4, y2 was -1, x1 was a positive 2, and y1 was a positive 3. So this is the square root of 4 minus 2 is 2 squared plus -1 minus 3 is a -4 squared. So 2 squared is 4. And -4 squared is a -4 times a -4, which is a positive 16. So we get the square root of 20. And then now we have to practice our simplifying our radicals. So the square root of 20, how can I split that up? Well, we can split that up into 2 times 10. 2 is a prime number, 10 is not. We can split that up into 2 times 5. 2 is a prime number, 5 is a prime number. So now we know that this equals the square root of 2 times 2 times 5. We get a pair of 2's that come out as a 2. So we get 2 times the square root of 5 as our final answer here. And you can see this on the grid as well. So our vertical side is 1, 2, 3, 4. And our horizontal side is 1, 2. And this side becomes 2 radical 5 when we solved for it. See how the coordinate grid forces a right angle there? So we're always solving for the hypotenuse when we're finding distance on the coordinate grid. Okay, so we want to find the length of the segment with endpoints at P, which is 1, 2. And Q, which is 5, 4. So let's label what we have on our coordinate grid to start out with. So if we have the grid in front of us, we can see that the horizontal side is going to have a length of 1, 2, 3, 4. And the vertical side is going to have a length of 2. And we're solving for C. Now, if we have a graph in front of us where we can count the horizontal side and the vertical side, we could just write out the Pythagorean theorem as a squared plus b squared equals c squared. It may be much easier for us to do that in a situation like this, where we can just count it on the graph to begin with. So we end up with 16 plus 2 times 2 is 4 is equal to c squared. So we get c squared is equal to 16 plus 4 is 20. Then we have to square root both sides of our equation. We get c is equal to the square root of 20. We have to simplify our square root, so the square root of 20. 2 is a prime number, 10 is not, so we can split that up into 2 times 5. So we have a pair of 2's, so a 2 comes out. We end up with 2 times the square root of 5. Which actually ended up being very similar to the problem we just did. Now, we won't always have a graph in front of us. So let's practice with the distance formula. On example F. So our distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So let's label. So we just have to pick one of the points to be the first point and one of the points to be the second point. Okay, so x2 is 3. X1 is negative 1. Y2 is negative 2. And y1 is positive 2. So 3 minus a negative 1 is a positive 4. And negative 2 minus 2 is a negative 4. 4 squared is 16. Negative 4 squared is also positive 16, because a negative 4 times a negative 4 is a positive 16. So that means our distance is the square root of 32. So now we have to simplify square root of 32. So we can do 2 times 16. 16, we can say 4 times 4. Even though 4 is not prime, we know we have a pair. So we know that they're going to come out of the radical. So d is equal to 4 radical 2. And then we can go ahead and label on our graph. So our horizontal distance was 1, 2, 3, 4. And our vertical distance was 1, 2, 3, 4. So we would have plugged in 4 and 4 for a and b if we had done a squared plus b squared equals c squared version of the Pythagorean theorem, and we would have obtained the same answer.